Good afternoon, ladies and gentlemen. So I'll be taking you through gadolinium. Gadolinium as a contrast agent. Gadolinium is a rare earth metal that is used to produce gadolinium-based contrast agents. So these gadolinium-based contrast agents are used to improve the quality of magnetic resonance imaging or magnetic resonance angiography during a diagnostic imaging procedure. Gadolinium-based contrast agents are usually given through the intravenous in the arm. They can be classified into linear agents or microcyclic agents. So, gadolinium linear agents are contrast agents that contain a linear chain of gadolinium atoms, while microcyclic agents are contrast agents that contain a ring-shaped structure of gadolinium atoms. Both types of agents are used to enhance the visibility of tissues and organs during MRI scan. The main difference between the two is that linear agents have a high relaxivity, meaning they can provide better contrast enhancement than microcyclic agents. Additionally, linear agents tend to be more stable in the body and have fewer side effects than microcyclic agents. Moving on. So the table here shows you the agent type and the product. So for example, gadoteric acid is a microcyclic agent. And moving on, gadodiamide is a linear agent. So I'll be proceeding. Mechanism of action. So gadolinium helps as an MRI contrast because it has 7 unpaired electrons. These are the greatest number of electron spins possible. Gadolinium molecules shorten the spin lattice relaxation time of voxels in which they are present. T1, also known as spin lattice relaxation time. So by spin lattice relaxation time, I mean is the time it takes for a spin system to return to its equilibrium state after being perturbed by external magnetic field. It is a measure of how quickly the spin in the system can relax back to their original state. T1 is typically measured in milliseconds and is used to characterize the properties of different materials. This results in T1 weighted images having brighter images. Gadolinium shortens also T2 relaxation time, thus resulting in a hyper-intense signal. All contrast agents produce changes in magnetic susceptibility by enhancing local magnetic fields. Pharmacology of gadolinium. The active ingredient in gadolinium-based contrast agents is a rare silvery earth metal which is called gadolinium. It reacts with the atoms and molecules in the body to make them easier to see in imaging scans. Gadolinium reacts with other chemical ions in the process called chelation to form gadolinium contrast-based agents. So by now I know you understand that gadolinium itself is a poisonous agent, is a poisonous metal, so it has to undergo chelation for it to be able to be used in the human body. It is then excreted by healthy kidneys through the urine before it becomes toxic. So if it remains in the human body, it tends to react with other ions in the body and causing health problems. Gadolinium based contrast agents help radiographers see abnormal tissues in MRI scans with more detail. They help doctors diagnose inflammation, tumors, and blood clots easily by producing distinct images. And the image below is a very good example of distinct image. Side effects of gadolinium. Gadolinium media have high risk of attaining nephrogenic systemic fibrosis. The risk increases in people who have had multiple MRIs with gadolinium agents and people with renal failure. Other common side effects of gadolinium, they include headache, nausea, dizziness, or feeling warm. Routes of administration. Gadolinium contrast media is given by intravenous injection. It is through a small needle in a vein in your arm. Two methods can be used, which are hand injection or automated injection. Hand injection is a manual process in which a person injects a substance into the body using a syringe. Automated injection is an automated process in which a machine injects a substance into the body using a needle or other device. Automated injection is more precise and efficient than hand injection, as it can be programmed to deliver precise doses of medication and can be used to administer multiple injections quickly and accurately. Additionally, or to add on, automated injection systems are often safer than hand injection as they reduce the risk of human error. Thus, gadolinium contrast agent can also be administered orally depending on the subject of interest. For example, oral administration is well suited for gastrointestinal tract scans. How gadolinium is used in the radiology department. It can be used to detect tumors or other abnormalities in the brain or spine, to identify blockages or narrowing of blood vessels in the heart or other organs, to diagnose diseases such as multiple sclerosis, stroke, and liver cancer, as well to evaluate joint damage caused by arthritis or other conditions, not forgetting to assess the damage to organs after heart attack or other trauma. With this, I thank you.